In this section here, we're going to be talking about implicit differentiation, and of course I'm just going to be working out some examples. So let's get started. And of course we'll start with something simple like x squared plus y squared is equal to 10. And what we're going to be wanting to find is we want to find dy over dx. Okay, we're taking the derivative of y with respect to x. So this is how this works. So we take the derivative of x squared, and that is 2x, plus, then when we take the derivative of y, we got to do something special. But we're going to take the derivative of this just like we'd normally, like if this were an x here. So the derivative of y squared is 2y, but every time we take the derivative of y, we're going to write dy over dx right next to it. And the derivative of a constant is 0. Now, I'm not going to work any of these like this, but let's say, for example, we were asked to find dx over dy. Okay, so this could be like a tricky question on the test, whereas the entire week or so you've been working implicit differentiation, but it's been the derivative of y with respect to x, but then all of a sudden you see it on a test and it's the derivative of x with respect to y. Well, basically what that means is you still do it the same way, except this time when you take the derivative of x here, you would write dx over dy. Okay, so keep that in mind. Alright, so here we are. Now what we want to do is just solve for dy dx. We want to just solve for dy dx. So that means I'm going to take this 2x over to the right hand side, so it becomes negative 2x, and we're left with 2y times dy over dx. Now what we're going to do is just multiply both sides by 1 over 2y, right? So 1 over 2y. And of course that'll get those to cancel out, and we'll be left with a dy over dx is equal to, and this will simplify down to negative x over y. And that's right, we're done. Alright, this time we'll work a little bit longer one. Let's say, for example, we had y cubed plus y squared minus 5y minus x squared is equal to negative 4, and we want to find dy over dx. Okay, I want to find out what the heck that is. So here it is. We take the derivative of y cubed, and that's just going to be 3y squared times, now remember we want to write dy over dx here. Okay, we take the derivative of y, write dy dx, plus, and then the derivative of y squared is 2y times dy over dx minus 5 times dy over dx, right? We're taking the derivative of this, and then this is going to be minus 2x is equal to, and the derivative of a constant is 0. So now what we want to do here is factor this dy dx out. Okay, and we're going to be left with 3y squared plus 2y minus 5. And I'm going to go ahead and take this 2x to the other side. And then, of course, you're going to just take this diagonally down, and so we'd be left with dy over dx is equal to 2x over 3y squared plus 2y And let's see, so we got 3y squared plus 2y and minus 5. Okay. So there's your dy over dx. Ooh, time to look at another one. So let's say that we have x cubed minus xy plus y squared, and that's equal to 4, and we're asked to find dy over dx. So that's what we want to find. So the derivative of x cubed is 3x squared minus, now because there's a minus here, I'm going to just put a bracket, okay? Now, because we've got a product here, and we're going to use the product rule, okay? So this is how this works. You take the derivative of x, which is 1, times, and rewrite the second function, plus, now we take the rewriting x, taking the derivative of y, and the derivative of y is 1, but then remember, because we're taking the derivative of y, we got to write dy over dx. Alright, and I'm just going to close that up. Plus, now we take the derivative of y squared, and that's 2y times, and because it's y, we got to write dy over dx is equal to, and the derivative of a constant is 0. Now, this minus sign right here, we're going to go ahead and distribute this across now. So we have 3x squared minus y, distributing this across, minus x dy over dx plus 2y times dy over dx is equal to 0. So now what we're going to do is we're going to get this 3x squared and this minus y. We're going to take it over to the right hand side of the equal sign. And I'm going to rewrite these guys here. And actually, if you don't mind, I'm going to switch these around because we have a minus sign right here. So I'm going to write 2y dy over dx minus x dy over dx. Now I said that I was going to take this 3x squared minus y over to the other side of the equal sign, and so it's going to be a positive y because it's minus here. Take it over, it becomes positive, and then minus 3x squared because it's a positive. Right, 3x squared, then we're going to go make it minus there, minus 3x squared. Alright, now I'm going to factor out this dy over dx. So we factor that out, and I've got 2y minus x now is equal to y minus 3x squared, so hopefully you're catching on now to the pattern. Now, of course, this 2y minus x, I'm going to take that diagonally down, and so we have dy over dx is equal to y minus 3x squared over 2y minus x. And we are finally finished. So hopefully you're catching on to this stuff. Okay, we are finding derivatives using implicit differentiation. Alright, got another good example here. We have x squared times y plus y squared times x is equal to negative 3, and we want to find dy over dx. Alright, that's what we want to find. So we have the product here. We have x squared times y, and we're going to use the product rule. So the derivative of x squared is 2x times y plus, and then we rewrite x squared times the derivative of y, and derivative of y is 1, but I'm not going to write 1 here. But remember, when we take the derivative of y, we also got to write dy over dx next to it. Plus, and we do the same thing here, derivative of y squared is 2y times x plus, and then we rewrite, I took the derivative of y, so we don't want to forget, I almost did, dy over dx here. Right, we took the derivative of y, we got to write dy dx. Plus, now I'm rewriting y squared, and the derivative of x is 1, and I didn't write 1 over here for y, but I'm going to go ahead and just write 1 for x. And then the derivative of negative 3 is 0. So now what we want to do is, let's see, all the stuff that's not attached to dy dx, like this term here and this term here, we're going to take that over to the other side of the equal sign. So that's going to end up becoming, let's see, negative 2xy, that would be this piece here, and then we're going to take this over, so minus y squared, and we're left with x squared dy over dx plus 2yx dy over dx. Now what I'm going to do here is my equal sign got a little close there, it looks like. Okay, I'm going to go ahead and factor dy dx out, so we have x squared plus 2yx dy over dx is equal to negative 2xy minus y squared. Now I'm going to go ahead and solve for now the dy dx, getting it totally by itself, and we end up with negative 2xy minus y squared over, right, taking this diagonally down, we have x squared plus 2yx. Now if you want, you could factor this negative out and bring it out front, which would make those two positive, but I'm just going to leave it right there. So there we go. We found dy dx. Okay, working some examples demonstrating implicit differentiation. Alright, so we want to find dy over dx, and what I'm going to do here is I'm going to break this up into x raised to the half times y raised to the half, so it's in radical form, and I'm going to break this up into exponential form, is equal to x minus 2y. And now we're going to differentiate implicitly. So we got it in exponential form, and now we're going to go ahead and take the derivative. Sorry if it sounds like I've already repeated that, but I have to crack these videos 5-minute increments and paste them together, so the continuity might be broken. Alright, I think we talked about continuity in an earlier section. Okay, let's get started here. Looks like product rule again. Got the product of x and y, and so let's take the derivative of x raised to the half. So we take the half, bring it out front, subtracting 1 from the exponent, and that of course would be negative a half. You did that. Half minus 1 is a negative a half, times y raised to the half. Okay, plus, now we're going to rewrite this x to the half, times, now we take the derivative of y raised to the half, so take the half out front, times y to the negative a half. And of course we're taking the derivative of y, so that means we got to write dy over dx right next to it is equal to, the derivative of x is 1, and derivative of minus 2y is going to be just minus 2, but don't forget the dy over dx. Alright, let's try to clean this thing up. And what are we going to do here? Let's see. I guess for now, I'm going to go ahead and okay, erase that. I'm going to rewrite this over here. This is y to the half over x to the half. And we took it down into the denominator because it have a negative exponent. And I'm going to take this 2 down here also. This is a half here. Just bring the 2 down. Plus, and I think on this one here, I'll just go ahead and rewrite this also. So this is x to the half. This time stays up in the numerator. And 2y to the half times dy over dx is equal to 1 minus 2 times dy over dx. Now what I'm going to do is I'm going to trade places. I'm going to take this minus 2y dy over dx over to the left. Alright, since we got a dy over dx over here, and then I'm going to take this stuff over to the right hand side of the equal sign. So we're going to end up with 2 dy over dx plus x to the half over 2 y to the half times dy over dx is equal to 1. Now I'm bringing this over, so this would be minus y to the half over 2 x raised to the half. Okay, hang in there. I'm going to now factor out this dy dx, and so we're going to be left with 2 plus x to the half over 2y to the half. Alright, is equal to 1 minus y to the half over 2x to the half. Then what I'm going to do is just go ahead and write dy over dx is equal to, this is going to be 1 minus y to the half over 2x to the half, and that's going to all be over this stuff here because we're going to take this directly diagonally down. So 2 plus x to the half over, run out of room. I guess I didn't have to run out of room, could have just done that. 2y to the half. Yeah, that looks like that. I'm going to rewrite this one more time and get it out of exponential form. To write small here, because I've run out of room. 1 minus, now this right here, we got a y to the half and an x to the half. We could actually rewrite this as we got a 2 down here. We can write this as 1/2 times the square root of y over x. Okay, that's totally legal. and that's because y is to the half and x to the half, over 2 plus, and I can do the same thing down here. Except this time x is in the numerator and y is in the denominator. Okay, and I think I'm going to end in that problem. Let's take some second derivatives. How about doing that? Okay, so we have 1 minus xy is equal to x minus y, and this time we want to find d2y over dx2. And that means first we got to find dy over dx first. So let's do that. 1 minus, I'm going to start a parentheses here, derivative of x is 1 times y plus x times derivative of y. I'm not going to write a 1 here. Instead, I'm just write the dy over dx. Alright, this is equal to, the derivative of x is 1 minus derivative of y is 1, except don't forget you got to write the dy dx. And now what we want to do is solve for dy dx in this problem. So I'm going to go ahead and distribute this minus across, so 1 minus y minus x dy over dx is equal to 1 minus dy over dx. Now what I'm going to do here is I'm going to go ahead and bring this dy over dx over to this side, and then in the meantime I'm going to bring this 1 minus y over to the right. So we're going to have dy over dx minus the x dy over dx. I'm rewriting this 1, and remember I'm taking this 1 minus y over, so this becomes a minus 1 and a plus y. Alright, and of course I'm going to simplify this down. This is just going to be left with y over here, and I'm going to go ahead and factor this dy over dx out. So this is going to become a 1 minus x and dy over dx, right, pulling it out there. And now I'm going to go ahead take this 1 minus x diagonally down. So we have y over 1 minus x dy over dx. So there's the first derivative. Now we're going to take the second derivative. Alright, so write that down. Remember it, because I'm going to erase the screen here and write that at the top. So write that down. Don't forget it. So we have dy over dx is equal to y over 1 minus x. Okay, and we are now remember, the goal here is we want to find the second derivative of y with respect to x. Okay, that's what we're looking for. So that means we got to take the derivative of this now. So it looks like we're going to be using the quotient rule here. So this is going to be d2 y over dx squared. So look, quotient rule, take the derivative of y. What's the derivative of y? It's just 1. But because we're taking the derivative of y, we got to write dy over dx. So that's the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator. So derivative of 1 minus x is just going to be negative 1, right? Derivative of 1 is 0. Derivative of negative x is negative 1. And of course that's all over the denominator squared, right? So this is the quotient rule. The good old quotient rule. So now let's clean this thing up. So we got d2y over dx2 is equal to, okay, so we're cleaning things up here. I'm going to write, you know what? We all know what dy over dx is. It's this guy right here. So we're going to substitute this dy over dx in for y over 1 minus x. How's that? Right, so this is going to be y over 1 minus x times 1 minus x plus, because we have a minus and a minus, that's going to make that a plus, y. And that's going to be all over 1 minus x quantity squared. Now look at here. I've got a 1 minus x up here and a 1 minus x down here. Right? We can cancel one of those out. We can cancel that out. Why can't we do that? That ought to work. Cancel that out. Rewrite this thing. So d2y over dx2 is equal to, we've got a y plus y, that's 2y, over 1 minus x quantity squared, and we are done. So that's taking the second derivative using implicit differentiation.